What's up, YouTube world? Today we're going to be learning how to graph a system of equations that is two equations as opposed to one. It could even be more than two, but in this case we're only going to be dealing with two. How to graph them to solve the solution. Now if you watch some of my other videos, you're going to realize that there's other ways that you can do it. You can use the substitution method and also the elimination method. So systems really have three different ways to solve, this being one of the methods. Okay, personally, I enjoy graphing. I think it's one of my favorite things to do in mathematics. So I appreciate the graphing method because if I have graph paper, and especially if these are written in slope-intercept form, which these are, that's y equals mx plus b form. This is stuff you should already know if you're working with a system. If written in slope-intercept form, then we have two equations that are basically ready to go. We can make the lines from them right away. And what the two lines are going to tell us is the solution that we're looking for. Now, oftentimes when you're doing the substitution method, there are a lot of steps involved with it. It takes time, and there's also a lot of room for error. So what I would recommend is when you get to the point where you understand each of all three systems methods that you can use, decide which one makes the most sense depending on what the equations are that you're given. In this case, both are in slope-intercept form. I have a graph provided. I am immediately thinking I'm going to graph these two lines, find where they intersect, and that would be my solution. Now again, point of intersection is what you're looking for. So I'm going to do a quick review in case you run into some scenarios that aren't as likely as the other. Okay, so I'll just do a quick sketch over here for you guys. If you have a graph and you have two lines that have different slopes, they're going to intersect at one point. Whatever that ordered pair is the solution, the two values for x and y that would make it true. Now you can also have a situation where your graph is given and your two lines have the exact same slope but a different y-intercept. In that case, they're going to rise and run the same at the same rate, and they're never going to cross. Now we're looking for a point of intersection. Two lines that have the same slope, they're never going to intersect. Okay, they're going to go forever and ever and ever and ever and ever. You're never going to find those two lines cross. Therefore, this would have no solution. So if you find yourself in a situation with two lines that are parallel, you know two things. You know your system does not have a solution. You also know that your slope is the same. Okay, and if you're really dialed in and you really understand this stuff, if you work your two equations out and they tend to be, let's say one's written in standard form, one's written in slope-intercept form, but you rearrange them into the same form and they're the exact same equation, you're going to get the exact same line. Nothing would be different about it. You'd have one line and then on top of that, you'd have a second line. Now those lines are intersecting meaning where they cross. Technically they're touching the entire time. They're two lines, one right on top of the other. So they are always touching or always intersecting. So this would be an infinite solution problem. There's an infinite amount of numbers that you could plug into the x and the y that would make both of them true. And wouldn't that make sense if they were both the same equation? Y equals x plus 2. Y equals x plus 2. If you put the same x and y in, no matter what they are, they're going to come out to be equal. Okay, so let's take a look here. Quick review: one solution, no solution, infinite solution. Now we move on to where we will have one solution. Now you might wonder, how do I already know that we are going to cross at one point? All I need to focus on is my slopes. If they are the same, I know one of two things. I will have no solution or I'll have infinite solution. In this case, I have -3 as a slope and a ghost 1. I call it a ghost 1 because we don't show the 1 as a coefficient in front of the variable when it's a 1. We just show the variable x. Okay, but if you want to put it down, by all means, write it down. That's your choice. Okay, if it helps you, use it. M is the slope. Quick little review. B is the y-intercept. This is stuff that we should already know when dealing with a system of equations and being asked to graph both of them. So let's get started. What do I do when I have a slope and a y-intercept, both in slope-intercept form? I'm going to graph the y-intercept, and then I'm going to use my slope as directions, just like directions on a map. This is your starting point. You found the treasure chest, or excuse me, you found the treasure map. This is where you begin. This is going to direct you on how to get there. So you start, and then you use this as rules of where to go. Okay, now, if it's negative, you're going to be going down and over. If it's positive, you're going to be going up and over. Always to the right. Okay, that's one thing that I see often with students is they want to, when they see a negative, they think working backwards, they start moving left. How do we read a book? Same way we would read a graph, from left to right. You're not going to open up a book and start on the right side of the page and read backwards. You're not going to do anything like that on a graph. Math, English, same thing. Okay, from left to right, move forward. So let's do this. I'm going to grab my marker right now, and we're going to get started with graphing this equation. Okay, first one is positive 10 for my y-intercept. Okay, what that means is I want to mark 10 on the y-axis. I go all the way up to 10 on the y-axis because that is my y-intercept. Now my slope is negative 3. I would recommend you just write the slope out as a negative 3 over 1. When you have a whole number, just put it over 1. This is your rise. In this case, it's negative, so it's a drop over a run. Always run to the right. If you can follow those two directions, you will be golden. So I go to this dot, I'm going to go down 1, 2, 3, over 1. From the next dot, down 1, 2, 3, over 1. 1, 2, 3, over 1. The more dots you give yourself, the more precise you are going to have, or the more precise line you're going to have. And in this case, I'm happy with what I have. So I'm going to grab a ruler real quick. And I'm back. Okay, so we now have our line. Go through the dots as carefully as you can. Try and get right through the middle of them. And you're going to graph your line. Easy peasy lemon squeezy. Now that's one of them. But we're working with a system of equations, which means we have two equations that we got to graph. Okay, we've got one taken care of. We're going to do the other one, and all we are looking for is where these lines intersect, where they cross one another. That will give us the solution. So y equals 1x minus 2. What is my y-intercept? Let's go back to y equals mx plus b. The y-intercept is the constant all alone without a variable. In this case, it would be negative 2. Okay, you have to look at the operation before the value. That is a negative 2. So what that tells me is to mark my very first dot at negative 2 on the y-axis. The y-axis, the vertical axis. Okay, so that's where we start. Now we follow the map. The map is going to give us directions on where to find the treasure. The treasure is being told, or excuse me, the directions are telling us that we need to go up 1, over 1. It's a whole number. Put it over 1, which means we are going to rise 1, run 1, always to the right. From this dot, I will do exactly that. Up 1, over 1. Up 1, over 1. Up 1, over 1. Boom, we hit it. As you notice, that dot has already been marked before. That will be our solution. So let me scratch this line on, and we can give our result, our answer. I'll line these up. We have our two lines. That is the point of intersection. Therefore, our solution is, start from the origin, 0, 0, 1, 2, 3 over to the right, 1 up. So as a coordinate, that would be written as 3, 1. The x-axis is 3 over, the y-axis was 1 up. This is our solution to the system, and you yourself can now graph two linear equations, both written in slope-intercept form, to solve a system. Thank you for watching. Please like, subscribe to my videos. On another one, I'll be showing you how to graph two equations that are not in this form. Tricky mathematicians. We're always going to give you something more challenging. So can you graph it? They're written in standard form? I don't know. Check in to the next video. Have a great day. You're going to do awesome on your upcoming test.